session, we discussed about the gradient descent algorithm to solve the single variable non-linear optimization problem. I explained by taking the function f of x equal to x square plus 5. Very simple. I explained the complete flow chart and the step-by-step algorithm also I explained. Right? Same thing will be applicable for every. So this thing I want to implement using the Python. I want to implement using the Python. Yeah. So I'm trying to minimize f of x, and that's equal to fx equal to x square plus 5. I want to use this one. Okay. So tell me, as per our previous discussion, what will be our first step? Our first step is read or randomly choose x value, and you have to initialize the maximum number of iterations you want to run this algorithm, and also initialize your learning rate, right? So that part I want to use now. So first I want to randomly initialize the x value. I want to call some library that is called a numpy library in the Python. So import numpy library as np. Now I want to initialize x value randomly. So x equal to randomly initialize x equal to np dot random dot uniform from the uniform distribution. You can randomly initialize any value between any range. So just I'm trying to choose -10 comma +10. You can choose any -100, -10,000, -1 lakh. That's your choice. From range, what is the lower limit and what is the upper limit of your search space for your x value? In that range, I'm trying to give the x value randomly. Some random value will be. So if you want to run this cell C, and you can see the x value. X value 9.13, and you can run again. And now the x value 3.71. Some random value between the -10 and -10 to +10. Choose another random value for the x. So after randomly choosing the x value, what next? Iter max. So initialize iter max, maximum of iterations equal to 100. And what is the eta? Eta equal to learning rate, that I consider as a 0.1. So these are the first three things we are going to initialize. Okay. So after initialization is completed. So what will be the next step? Calculate the gradient, right? So calculate the gradient. First, I want to calculate the gradient. GRAD, gradient equal to. So what is the gradient of x square plus 5? What is the gradient of x square plus 5? We know 2 into x. So 2 multiplied by x. Okay. So gradient of x square plus 5 equal to 2 multiplied by x. That is the gradient. So after calculating the gradient, what next? Calculate the delta x, step length. So del x equal to step length equal to minus eta multiplied by gradient, right? See, minus eta multiplied by gradient, that's the delta x. After calculating the delta x, update the x value, x equal to x plus delta x, x equal to x plus delta x. So this x will be repeated. So these three steps should be repeated. These three steps should be repeated. That means we have to include these three steps in a sum. We have to include these three steps in some iterative loop. That may be a while loop or maybe a for loop. Okay. So I want to use the for loop now. So I want to use the for loop. So for iter in range of So what is the range? How many iterations you want to run? That already given iter max. That means 100 iterations I want to run this loop. So terminate that line with a colon. That. So these three lines will be repeated. Right? This completed. This problem completely. So these three lines will be updated. These three lines will be updated and calculated for the 100 epochs. For the 100 epochs. Why 100? Because I said the max equal to 100. That's it. Now we want to see the output. So print my optimized x value x equal to x. So now run this part first. So just run this algorithm over. Now see the output. What is the value? 1.5 into 10 to the power of minus 9. Almost equal to 0. So you can use round x equal to 0. Right? That's the solution. We know, right? F of x equal to x squared plus 5. We know that at x equal to 0, my f of x value equal to minimum. And the minimum value of the f of x equal to. So we know that if you want to know the minimum value, so print f of x. F of x equal to, what is the f of x value? F of x value equal to x square, x into x plus 5. So I have my optimal solution. That means I will get the f of x value minimum. That minimum value equal to 5, and I will receive this I will reach this minimum value when x equal to 0. So this is how we can write the code for the gradient descent algorithm for the single variable nonlinear optimization problem. So same thing you have to code for the second assignment also. You can see in the canvas, I gave the second assignment. So the instructions are available. By seeing those instructions, just you can so all the things are available. Now you have to work on it. So find the global minimum point for the value of function f of x equal to x to the power 4 plus 3x square plus 10. Don't go for this manual calculation. These are the things I have given to my students. And you have to find a solution using the Python programming. You have to write a Python code by taking all these codes as a reference. And now solve this assignment 2, and also you have to solve this assignment 3. Both assignments you have to solve. Total 3 assignments I am giving for today, but you have to submit anytime, but before closing of the FDP. Before closing of this FDP. Okay, so I hope you are able to understand how I am writing the code for the gradient descent algorithm to solve the nonlinear single variable optimization method. Nonlinear single variable optimization method. It's a clear, right? I hope. Okay. So next we will discuss about the multivariable, because in your machine learning or deep learning, you can't find only single model parameter. You have the multiple model parameters. If you go to the deep learning, you have the very, very complex deep learning models. You have the more number of model parameters. So still we can use the gradient descent algorithm. But I am trying to explain that also very easy for you. I am trying to explain the multivariable nonlinear optimization problem using the gradient descent algorithm that we are trying to work on it. Later, we will try to implement it. Now move to the next point, next task. So I think if you understand the previous session, you are easily understand this part also very easy. So next topic is multi-variable non-linear optimization problem using gradient descent algorithm that we are trying to work on it. For to explain this thing, I am trying to take very, very small case study, that is f of x comma y problem, f of x comma y equal to x square plus y square plus 10, let us assume. So I'm trying to minimize this one. That means this is called as a non-linear, because I have the x square and y square terms, non-linear. Multivariable, because I have the two variables. Unconstrained, because I don't have any constraints. So this is called as a multivariable unconstrained nonlinear optimization problem. I want to solve this one using the gradient descent algorithm. Using the gradient descent algorithm, I'm trying to explain now. Okay. So now same thing, same concept what we discussed in the previous session. You can apply same. So what will be the step 1? As usual, randomly choose x and y values. X and Y values. Randomly choose X and Y values. So that means you can choose any random X and Y values. I am trying to choose X equal to 2 and Y equal to 3. Let us do. And in the step 1, what are the other things we have to initialize? Another thing is called as the iter max. You have to initialize iter max equal to 100 something. And you have to initialize the learning rate as a 0.1 or something. We have to initialize. Actually, I forgot to explain about the impact of the learning rate on the training process or the updation of the model parameters. Okay, we will discuss by end of the session. So now, oh, 1 minute, please. Okay, everything good. Okay, theta equal to 1. So what will be the next step for us? So based on the things what we discussed in the previous session, so what may be the next step? What may be the next step here? Anyone? What may be the next step? Step 2. You can use your chart box or you can unmute yourself. So first step is random initializing the our destiny variables X and Y. Initialize X equal to Y equal to randomly chosen. And the mag number of epochs, number of iterations 100 and data equal to 0.1. What will be the next step? Step 2. And also set iter equal to 1. First iteration. We are in the first iteration. So what next? Anyone? Please unmute yourself or you can text also. Is in the chat box. What may be the next step after initializing all the parameters? Okay, fine, no issue. So next step is calculate the gradient, right? So if you observe our previous one, so what's the next step? You can see we are going to after initialization, we are trying to calculate the gradient, but here calculate the gradient with respect to X only because we have the only one variable. But in the second case, it is the multi-variable. We have the two variables X and Y. So you have to calculate the gradient with respect to X, and also we have to calculate the gradient with respect to Y. That is the second step. So calculate the gradient. So calculate gradient gx. So gx equal to, how we calculate the gradient value? Gx equal to, so that's called dou f of x comma y dou x at x equal to x naught initial value. Similarly, calculate the gradient with respect to y, that is called as the dou f by dou y at y equal to y naught. So what is the value? Dou f by dou x. Here, what is the dou f by dou x value? So dou f by dou x value is nothing but, so that is the 2 into x, that is the 2 into 2, that's equal to 4. And similarly, dou f by dou y equal to 2 into y, that's equal to 2 into 3, that's equal to 6, because x equal to 2 initial value, that comes here, and y equal to 3 initially, that comes here. Okay. So after calculating the gradients, what will be the next step? After calculating the gradients, what will be the next step here? We are calculating the step length. Previously, we had the single variable, so only delta x. If you have the multi-variable, you have the multiple change in step. That means you have to update your x value, you have to update your y value also. So how we update the x and y values? That comes under the step number 3. That comes under the step number 3. Okay. So in step number 3, so calculate delta x and also calculate delta y. How we calculate the delta x? Delta x equal to minus eta dou f by dou x at x equal to your initial x value. And similarly, delta y equal to minus eta dou f by dou y into y equal to y naught, your initial y value. At that means current x, current y value. Okay. So minus eta equal to 0.1. And what are the dou f by dou x at current x value? We already calculated dou f by dou x at current x value 4. So you can incorporate 4 here equal minus 0.4. Similarly, minus eta equal to 0.1. And what are the dou f by dou y value already calculated? That is the 6. That's equal to minus 0.6. That means how many number of variables you have for every variable, with respect to every variable, you need to calculate the gradient. And after you have to calculate the step length for every variable. So after that, step number 4 is you are going to calculate the update. We are trying to update the each variable. So we have to update the variable update. Next step is update. How we update? x equal to x plus delta x and y equal to y plus delta y. So what the x value? That means current x value. What is the current x value? 2, right? Initialize. Current x value 2 plus what is the delta x value? Minus 0.4. And what is the current y value? 3 plus what is the delta y value? Minus 0.6. Now what is the value? It is the 1.6 and it is a 2.4. We are getting the x and y values, new x and y values. So again, go back to with the new x and y values, again calculate the gradient, again calculate the delta x, delta y value, step length value, again update the x and y values. These 3 steps will be repeated for every iteration. So when it will be stopped, that is based on the number of epochs, maximum number of epochs what you fixed at the time of the initialization. Up to those times your algorithm will be executed. Okay. So what may be the next step? Step number 5. That's equal to you are going to update your iteration. Iter equal to iter plus 1. And next number is step number 6. That's called. Now check if your current iteration value is less than or equal to maximum number of iterations that you initialized. This is the convergence criteria because you want to run the algorithm based on number of iterations you fixed. Right? So if it is a true, where to go? If it is a false, where to go? If it is a true, if it is a false, let us assume iter value is not less than or equal to iter max. That means iter value is greater than number of iterations what you initialized earlier. Then simply we can stop the algorithm. Stop algorithm and print your optimal solution. Stop algorithm and print a solution. Okay. That is the step number 7. If it is a false, then go to step number 7. False means if iteration is not less than or equal to iter max. That means iteration value is greater than iter max, then you can stop the algorithm. If the iteration value, current iteration value is less than or equal to iter max, if the current iteration value is less than or equal to iter max, then where to go? If the current iteration value is less than or equal to iter max, then where to go? So any idea, anyone? So if the, so here you are able to see some. So all the steps are available. Suppose if the current iteration value is less than max the number of iterations that we fixed at the time of the initialization, then which step we have to go back? Which step we are going to back? You can unmute yourself or you can use the chat box also to give the answer. If it is a true, that means your current iteration value is less than or equal to iter max, then where to go? No idea? Okay, then you're going to go back to, if the current iteration is less than number of iterations, then you go back to your step number 2. Again, going to the calculation of the gradients, later calculate the delta x, delta y, later update the x and y value. So go to step number 2. Go to step number 2. So this is the complete algorithm that we can use for the gradient descent algorithm in case of the multivariable optimization method. So again, I want to draw the flowchart for this one. So you may go for the start. So what is the first step here? You have to randomly initialize x comma y, and also you have to set iter max value and you have to set the eta value, right? Now, and also you have to set iter value, iter equal to 1. That means we are in the first iteration. So now what you have to do? Calculate the gradients. So gx, and you have to calculate the gy gradients. Okay, gradient nothing but dou f by dou x you have to calculate, and dou f by dou y you have to calculate. So after calculating the gradient, what you have to do? Calculate the delta x and delta y value. Delta x equal to minus eta into dou f by dou x, and delta y equal to minus eta into dou f by dou y, nothing but the gy. So calculate the gradients as well. So after calculate the delta x and delta y, So where to go? You are going to update the x and y values. X equal to x plus delta x and y equal to y plus delta y. Update x and y values. So after updating the x and y values, what we have to do? Iter equal to iter plus 1. That means we are updating our iteration count. We are in the first iteration. After completing these 3 steps, now we have to update our iteration count. So next step is you have to check whether our iteration value is less than or equal to iter max or not. If it is no means your iteration value is greater than, then you can stop algorithm and print all the output values. If it is yes, true, then you are going to the second step where you are going to calculate the gradients. Okay, so this is how we are going to use the gradient descent algorithm for the multivariable nonlinear optimization problem. Multivariable nonlinear optimization problem. Okay, fine. So this is the how we can use the multivariable nonlinear optimization problem. But thing is, it looks very simple. But really, if anyone wants to understand the machine learning, that means parametric based machine learning models or neural networks or anything, then this is very important. If you understand this one, then you can easily understand the back-end operation of every neural network models. That's why I am more concentration on this part in the first day completely. Okay. So now I'm trying to explain the same problem. I'm trying to implement the same problem using the Python as well. So what is our objective function? Our object function is f of x comma y equal to x square plus y square plus 10. I'm trying to minimize this objective function. And that means I'm trying to find the x and y values where my function will be minimum. Okay, that I'm trying to implement using the Python. Fine. So here, so what will be our first step? First we have to write. So my function is here trying to minimize. I'm trying to minimize f of x comma y plus equal to x square plus y square plus 10. This is what I'm trying to minimize. Okay, using the gradient descent algorithm using GDA. So this is the multivariable because x and y, non-linear because we have x square and y square, unconstrained because there is no constraint. So it's called a multivariable non-linear unconstrained optimization problem. I'm trying to solve using the gradient descent algorithm. And moreover, most of the machine learning and deep learning algorithms or models are works based on the multivariable non-linear unconstrained optimization problems only. Now this is the problem. Now first tell me what is our first step. We have to randomly initialize the x and y values. Random initialize the x and y values. Okay. So for random initialization of x and y values, we are trying to import the NumPy library. So import NumPy as NP. Import NumPy as NP. Okay. Now I want to initialize the x value first. So x equal to np dot random initialize. So random dot uniform some range. I'm taking the minus 10 comma plus 10. You can took any range. Similarly, random initialize the y value. Y equal to np dot random dot uniform random uniform in the range of minus 10 comma 10 x and y values. Okay. Now x and y values are initialized. So what next we are trying to initialize? You can check our where is my notepad? This one. So after randomizing x and y values, now itermax eta we have to set, right? So you can check. You can use itermax, or generally in machine learning we will use a term called epochs. Epoch, that means max number of iterations. Just I am trying to use the 100 epochs. Max number of iterations 100 epochs. Now max number of iterations 100. And it learning rate that's equal to 0.1. So this is the initialization part. Just simply execute. That's our right. Next. Now what is the next step after initialization? Calculate the gradients. So calculate the gradient gx equal to 2x. Okay. So that means 2 multiplied by x. Similarly, gy equal to 2 multiplied by y. You can see 2y, 2 multiplied by y. After calculating the gx and gy, next step is delta x and delta y. Delta x and delta y is nothing but minus eta into dou y by dou x, nothing but the gx, dou y by dou y, nothing but the gy. That means delta x equal to minus eta into gx, delta y equal to minus eta into gy. That's we have to write. So del x equal to minus eta multiplied by gx and del y equal to minus eta multiplied by gy. That means delta x equal to minus eta into gradient. So after calculating the step lengths, delta x and delta y, what is our next step? Update x equal to x plus delta x, y equal to y plus delta y. That also you have to complete. X equal to x plus delta x, y equal to y plus delta y. That's over, right? Now, I want to repeat all these steps for the 100 epochs, right? So we have to keep these steps in a for loop or in a while loop. Just I want to use the for loop. So for iter in range of your iter max, that is in range of your iter max, that means epochs. Epochs, okay? Done. Done. Okay. So this is your iterative process. So after completing this iterative process, if you want to print the output, you can print here. So print x equal to what is the x value? So you can use round otherwise. So ROUND, what is the final x value you are getting after 100 epochs? So you have to try to round off it near value. You have to round it off. So round x, and similarly print. So what is the y value? So y equal to. So you have to use your final y value and you have to make it round. We know to round of nearest round 0.2 nearest round value is 0. 0.7 nearest round value equal to 1, like that. So after again you have to write print minimum value of f of x comma y is equal to, you can get how we get the f of x comma y, x square plus y square plus 10. So you can write that part directly. X into x square plus y into y square plus and 10 can write. Now run this algorithm completely. That's over. Now you can run this output. So you can see we know value, because I'm taking the very small examples because you have to understand. If you don't know what is the right answer, whatever the computer giving, we feel that is the right answer. But we are taking the very small example. So we know already. So we know already that is x square plus y square plus 10. Where it will be negative, where it will be minimum. We know at x equal to 0 and y equal to 0, our function will be minimum, and minimum value of the function equal to 10. By seeing that function, we can easily tell. So you can see x equal to 0, y equal to 0, and finally minimum value of f(x, y equal to 10. That's how gradient descent algorithm will work for the multivariable non-linear unconstrained optimization problem. And this is the implementation using the Python. And we have the 2 assignments, or total 3 assignments for today. One is based on the linear optimization. Second is based on the non-linear optimization but single variable. And third is based on the non-linear optimization but multivariable. So you have to work on these 3 assignments in the Google Colab and upload into the Canvas. Okay. So this is how we are going to implement gradient descent algorithm using the Python and linear optimization using the Python. That all we discussed till now. And I'm trying to explain GDA implementation and linear optimization implementation using the MATLAB as well. Okay. So after that, we will discuss how this optimization, how we can correlate this optimization with the deep learning, all things we will discuss. Okay. So I'm trying to finish. Raghuram sir, you want to say something?
No, No, sir, no. Hello.
Okay, fine. Done. Fine. So I hope you understand, right? Implementation of the gradient descent algorithm for the single variable, for the multivariable using the Python. Okay. Now we will try to work with the MATLAB as well. Okay. So I want to solve the same problem using the MATLAB. For that problem, I think you are able to remember. I think where it is ML optimization and linear optimization. Yeah. No, not this one. Yeah. Assignments. Right. So this is the same case study I'm trying to implement using the MATLAB also. Maybe some people prefer Python, and especially non-CS people prefer MATLAB. So that's why I'm trying to explain with the MATLAB also. So whatever it may be, whatever the case study you have to convert into the mathematical modeling. It is readily available. Now, based on this mathematical modeling, we have to use either Python or MATLAB or any other languages to work on it. Okay. Now going to MATLAB. So going to MATLAB. So this is the code you can write. Otherwise, I will copy once again. So you have to use PLC. So I want to clear my command window. This is my command window. I want to clear it and clear all. So whatever the workspace variables I have, I want to clear all the workspace variables. So what is the workspace variables? You may have out. This is called the workspace. Already some variables are there. I want to clear all those variables. I want to clear this command window also. So I want to save this file. Linear opt. Something like chocolate factory, Choco example. Okay. Now run this piece of code. So you can see all the variables in the workspace removed, cleared, and all the content available in the command window also cleared. That's it. Now tell me what we did in case of the Python. So first we are taking the object function information. So what is our object function information? What is our object function information? OBJ information. OBJ, what is the OBJ information? Yeah. Actually, I am trying to maximize. This is our mathematical modeling. We are trying to maximize 6x plus 5y, but our MATLAB or Python will support for the minimization problem. So trying to convert into minimization problem, then we have the -6 and -5 coefficients. So that object function you have to do it. OBJ equal to -6, first variable coefficient, semicolon, and one second variable coefficient -5. OBJ is over. Okay. Now, what about the coefficient matrix of a inequality constraint? So what are the coefficient matrix of the inequality constraint? 1, 1, 3, 2. So that you have to write A. You can write anything. AUB, or you can write A underscore UB or AUB. That's equal to. So what are the values? First row 1, 1. So 1 space 1, 1. First row completed, and second row 3, 2. Second row 3 and 2. Okay. Now what about the constant matrix BUB equal to? What is the constant matrix BUB equal to? 5 and 12. So 5 semicolon 12. Okay. So AUB BUB is completed. Okay. Now, actually, parts all of you please listen. So in case of the MATLAB, so your X value, that means solution will be coming. Your solution will be coming. So X equal to solution will be coming. X equal to lin prog, same method. Lin prog, same as your Python. Here also you have the lin prog method. Lin prog method. But it is asking your objective function obj. It will ask next. It will ask coefficient matrix of the inequality constraint AUB, constant matrix of the inequality constraints BUB, And it will also ask coefficient matrix of the equality constraint. So what I mean to tell you is here we have the only inequality constraints. Suppose if you have the equality constant like 2x plus y is equal to 10 and 5x plus 20y is equal to 100, like this, let us we have, then its inequality constant matrix is 2 and here 1 and here 5, here 20 multiplied by x and y, that's equal to 10 and 100. So this is called as the AEQ and this is called as the BEQ. It is related to the equality constraint and this is related to the inequality constraint. Hope you understand, right? In our case, AEQ value, BEQ value are 0, null, nothing, no equality constraints are available. So because there is no equality constraints are available, simply you can write a empty matrix like this. Because otherwise you can write AEQ equal to no information, sorry, and BEQ equal to no information, and call those values AEQ and BEQ also you have to call. Understand? Same thing I'm writing here. So FAB, or I'm using here AUB and BUB I am using, no problem. And A equivalent and B equivalent. So here writing the A equivalent and B equivalent. And lower boundary and upper boundary and initial values, and you have to use the options also. Okay, na? So you have to call lower boundary and you have to call upper boundary. You have to call initial values. There is no initial values, empty, and you have to call options. What are the options we will discuss now? So this is the actual flow. This is what your linprog method is expecting. Linprog method is expecting. First, OBJ, right, this is related to your objective function. AUB related to your inequality constant. BUB related to your inequality constant, but the constant matrix, AUB is the coefficient matrix. AEQ, that is called as a coefficient matrix related to the equality constraint. Nothing is there. And BEQ is nothing but the constant matrix related to the equality constant. Nothing is there. Right? Now, our problem, there is no equality constraints. We have the only inequality constraints. There is no equality constant. That's why this is empty. Hope you understand. If you have, for example, you have the constraint like this, let us assume. If you have the constraints like this, then what are the AEQ 2, 1, 5, 10? Then you have to write 2, 1, 2, 1, and 5, 10. That is the AEQ. And what about the constant matrix for the equality constant 10 and 100? So you can write here 10 and 100. But here in our case, this is not exist. Only for explanation purpose only I have taken this one. That's why. So this information is not available. Just remove. This information is not available. Just simply remove. Okay. So this is. Next, what about the lower boundary? LB. Lower boundary equal to what are the lower values? X and Y. Lower values are zeros. So 0, 0. And what is the upper boundary? Upper boundary is nothing but the infinity. So INF and INF, infinities. Okay, you have the infinity. Okay, so you have the upper boundary, you have the lower boundary also over. And options, what are the options? So here options, sorry. Options equal to, you have to write options equal to optim options. So what it will give here is, sorry. So otherwise I will copy directly. I will explain. Options equal to optim options. You have to write which function you are calling and algorithm. You have to write which algorithm you want to use. Here I want to use the interior point method, or you can use the simplex also. In the Python also we are passing one method, simplex. Like that you can pass the method, what method you want to call. So you can use simplex method or you can use the interior point method. So that options you have to call here. That's it. So you have to, this is the only not mandatory. Just I'm trying to clear my command window and trying to clear my workspace. Your object function values, your inequality constraint coefficient values, and inequality constraint constant values. This is the equality constraint coefficient values. equality constraint constant values, lower boundaries, upper boundary, and which method you want to use. That is called options you have to pass. And those options you have to pass it to the linprog method. And finally, you can write X that will give the solution. So if you run this cell, so finally you are getting the values X equal to 2 and Y equal to 3. Same thing we are getting previously for the Python also. Somewhere here, we are running see X equal to 2 and Y equal to 3. So in the MATLAB also, we are getting the same X equal to 2 and Y equal to 3. That's how we can solve any linear programming problems, linear optimization problems using the MATLAB. Almost both are correlated, both Python and MATLAB. So you can use either MATLAB or you can use any MATLAB or Python also to solve the linear optimization problems. So this is the thing. So this is not mandatory again. CLC clear all only to clear my command window and workspace. You have to pass the object function coefficients. You have to pass the inequality constraint coefficients. You have to pass the constant values of the inequality constraints. And you have to pass the coefficients of the equality constraint. You have to pass the constants in the equality constraints. You have to pass the lower boundary values of your decision variables. You have to pass the upper boundary values of your decision variables. You have to give the options, which algorithm you want to use. Here I want to use the interior point method, or if you want the simplex method, you can write simplex, simplex, simplex. And finally, you can call your linprog method. So in the linprog method, you have to pass your object function, you have to pass your inequality constraint, you have to pass your inequality constraint, you have to pass your equality constraint, you have to pass your lower boundary and upper boundary, and there is no initial point is not there, so it is empty. And options is which method you want to call. That's it. So if you run this well, it will give the solution like X equal to 2 and Y equal to 3. That means you are telling your client that two units of A type chocolates and 3 units of B type chocolate. If the client will produce for a particular day, he will get the maximum profit. Hope you understand what I'm saying. Then, so that's how we can use the MATLAB. Okay. Similarly, you can use, we will discuss about the GDA using the MATLAB, gradient descent algorithm using the MATLAB. Okay. So say I want to save this one as a GDA single variable, GDA single variable. Okay, gradient descent algorithm for the single variable. So you can use CLC, clear the command window, clear all, clear the workspace. You can see I want to clear the command window, clear the workspace. If you run, both are gone. Now, tell me, I want to initialize the X and Y values. I want to use the same problem. So what problem we consider here? I think f of x equal to x square plus 5. I'm trying to minimize this one. Okay. So I want to use the MATLAB. Okay. I want to use the MATLAB here. So for the first step, we have to randomly initialize the x values. So lower limit and upper limit we have to call. So I am trying to give LL, lower limit is -10. That means from the -10 to +10, I have to randomly initialize the x value something. You can choose lower limit, upper limit, your choice. Here I'm considering the -10, same value I consider in the Python also. Lower limit is -10. And upper limit is +10. In this -10 to +10, I want to randomly generate the x value. So x equal to lower limit plus rand. So rand multiplied by upper limit minus lower limit. This is the code which is used to generate the random number between the -10 to +10. So if you want to see the output, you can run here. X value 6.29. And again run 8.11. Again run -7.4. Again run 8.26. That's the randomly generated X values. That's what required initially. That's over. So after that, what we are going to initialize? Epochs. Number of epochs, I want to use the 100 epochs. And eta, learning rate, that's equal to 0.1. That also we discussed. So eta equal to 0.1, sorry, eta equal to 0.1 and epochs equal to 100, eta equal to 0.1. So what next? All are initialized. So we are going to use 3 steps. What are the 3 steps? able to remember, 3 steps are: first is calculate the gradient. Gradient equal to G equal to 2 multiplied by X, and gradient equal to 2 multiplied by X. And what the delta X? Delta X equal to, what is the delta X value? I think you are able to remember delta X value equal to minus eta multiplied by the gradient. So I will write the gradient as a gx, otherwise there is a gradient with respect to the variable x. Gradient with respect to the variable x. So delta x, after calculating the delta x, after calculating the step length, so that is the x equal to x plus delta x, update the x value. So these are the 3 steps. And these 3 steps will be repeated based on the number of epochs what we initialized at the time of the initialization. Okay. So now you have to keep these 3 lines in a for loop. I want to use the for loop for, but in Python, it is some syntax is different. But here, iter equal to first iteration to last iteration. That means epochs. Like that, you have to call. In the Python, we are using the for iter in range epochs. That is the syntax for the Python. But in the MATLAB, for iter equal to 1 epoch. That means 1 to epoch. Epochs equal to 100, right? So 1 to 100, that will be repeated. And you have to close this for loop. Just end. Close this for loop, end. That's it. Okay. So if you want to see the x value, you can write x value here. Now run this code. For the x value, you are getting x equal to something like this. So you can use the round also. Round means you can use round, round. So nearest round value, I want to keep. Nearest round value, round, nearest round value, I have to keep. Now you can see the answer. Your x value equal to 0. X value equal to 0. Same thing, right? We discussed in the previous Python also, we implemented, we got x equal to 0. Otherwise, we will go back and see the value x equal to 0. In MATLAB, I'm implementing, we are getting the same thing, x equal to 0. So I think it's clear for you, right? And next, we try to implement for the multi-variable also. Same problem, x square plus y square plus 10. And trying to implement the gradient descent algorithm for that objective function for that optimization problem using the MATLAB. Again, CLC, and you can write clear all. What next? What next? So you can write lower limit minus 10 and upper limit plus 10. You can choose any. You can choose any upper limit and lower. Now you have to randomly initialize the x and y values. 2 variables, right? I won't write the function here. Otherwise, if you forget, I want to solve f of x comma y. That's equal to f of x comma y. That's equal to x square plus y square plus 10. This is what I am trying to minimize. So minimize. That's it. Minimize f of x comma y equal to x square plus y square plus 10. Done? Okay. Just a minute, please. Yeah. Right? So tell me, what is the first step? Initialize x and y values randomly. How we initialize x value? X equal to lower limit is a piece of code that we discussed in the previous code in MATLAB also. Lower limit rand multiplied by upper limit minus lower limit. Similarly, y equal to lower limit plus rand multiplied by upper limit minus lower limit. Okay. So you can run, if you want, you can run this code, but it asks saving. So GDA multi-variable. Multi-variable. Okay. Multi-variable. Okay. So now run this cell and see the x value. So randomly it's saying x equal to 9.15 and y equal to 9.29. If you run again, it will give some other x and y values. So x equal to minus 6.8, y equal to 9.41. So randomly choosing some x and y values. That's it, initialization. So after that, what you have to do? Epochs, number of epochs you want to run this algorithm. Let us assume 100 epochs. And eta, learning rate, that's equal to, you can take the 0.1. Then initialization completed. Now what are the 3 steps? Gradient calculation, step length calculation, updating the variables. So gradient calculation with respect to x and y. Here is the two variables you have. So you can calculate the gx equal to what is the gradient of dou f by dou x. That is the 2 multiplied by x. Next, dou f by dou y, that is called the gradient. Gy equal to 2 multiplied by y. Hope you understand, right? What is the gradient of this function with respect to x? 2x. What is the gradient of the function with respect to y? That is the 2y. Okay. Hope it's clear. So after calculating the gradient, what next step? Delta x and delta y agree. So delta x equal to del x equal to what is the del x value? Minus eta multiplied by dou f by dou x. That is called dx. Similarly, del y equal to minus eta multiplied by dou f by dou y. That is called as a gy. That's over. So gradient calculation also completed. After calculating the gradients, after calculating the step length, what is the next step? Update x and y values. So x equal to x plus del x and y equal to y plus del y. That's it. So these are the 6 steps need to be repeated over the 100 epochs. Over the 100 epochs, we have to repeat these 6 steps. So for that one, you have to keep it in the for loop. So for it equal to 1 colon epochs. So 1 to 100 epochs, you have to run this iterative loop for loop and close this for loop using the end. Whereas in Python, there is no end separately. And whereas Python, there is the indentation, but there is no indentation in the MATLAB. That small things you have to remember. Small things you have to remember. Okay. So if you want to see the outputs x and y, so you can run this cell. So finally, so you can round it off. You can round 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 your x value, and also you can round your y value. That's it. You can run. You got x equal to 0 and y equal to 0. Got x equal to 0 and y equal to 0. Okay. So the same thing, right? In the Python also we are getting x equal to 0 and y equal to 0. That's it. So this is how we can use both Python and MATLAB to implement the gradient descent algorithm for the single variable optimization, multivariable optimization, unconstrained nonlinear optimization. So that we are trying to understand. So hope you understand the implementation of a gradient descent algorithm for small problems. Right? Fine. Now, that's fine. And the last thing that I'm trying to discuss in today's session is how I can correlate. How I can correlate the things what we discussed, gradient descent algorithm optimization for the deep learning. For the deep learning. Okay, fine. Yeah, fine. Okay. Till now we discussed about the gradient descent algorithm for a single variable nonlinear unconstrained problem and multivariable nonlinear unconstrained problem. Now I'm trying to explain how this optimization will be helpful in a deep learning. Fine. Sorry. Sorry. Fine. That till now that the optimization topic was completed. Now we will try to correlate how this optimization is useful. Okay, fine. Let's assume I have a small problem. That is, I am trying to forecast the load on a, okay, not load, maybe see, AI will be common, machine learning is common, deep learning is common for all the branches. Only thing is data will change. So generally electrical people may talk it as a load, whereas civil people some other parameter. For agriculture people related to the crops data. Okay, no? So anyhow, I will use some common data. Let's assume I want to build some deep learning model. I want to build some deep learning model. So this is my deep learning model, DLM, deep learning model. So deep learning model means it contains some multiple parameters inside this model. Multiple parameters inside this model. Okay. And I want to use this deep learning model to predict the temperature at a particular day, to predict the temperature at a particular day. So I want to call it as a T of D, temperature at a particular day. I want to calculate, I want to predict, I want to forecast based on the last 3 days temperature data. That means I am trying to predict the temperature in SR University today based on the temperature available in the SR University 1 day before, and based on the temperature available in 2 days before, and the temperature available at the 3 days before. Based on these 3 points, 3 things, I'm trying to forecast the temperature at the current day today. So this is my requirement. So I want to use one deep learning model. So I want to tell one thing, that is whether it's a machine learning model or deep learning model is nothing but some mathematics behind that model. There's some mathematical relation, trying to build some mathematical relation between your inputs and outputs based on some model parameter values. These are the some model parameters. Based on these model parameters, it trying to build some approximate relation between the output and input. Whether it's a machine learning model or deep learning model, what it will do is that model has some mathematical relation behind. It tries to build some mathematical relation between your input and outputs, between it inputs and outputs. So what the relation, that is depending upon the model to model. So linear regression model, it try to build some linear relation between the inputs and outputs. Okay. And whereas the neural networks, it will give us some more complex relation trying to build between the inputs and outputs. So, but that relation is based on some mathematics, some mathematical relation in terms of the model parameters. That is not given outside, that will be inside your deep learning model. You can't visualize it. But we are trying to, I'm trying to explain that part also from tomorrow. As of now, try to remember, deep learning model is a model. We try to build some relation between the outputs and inputs in terms of a model parameter that exist inside your deep learning model. Inside the deep learning model, there are some model parameters. These model parameters will give the relation between the input and outputs. We try to build some relation between the inputs and outputs. Okay, fine. Now, what it will do here is, we are whenever we are going for the training of a deep learning model, we have to use the data. So let's assume I'm taking the past data, like I'm taking the past data d-1 and t of d-2 and t of d-3 and my t of d, there is the output variable. I have the past data. So lakhs of thousands of samples of data is available. Okay, good. Now what I will do is, I will take the sample 1. This is the first sample. The first sample t of d-1 value going to this part, and t of d-2 value coming here, and d-3 value coming here. And all these 3 values are doing some mathematical process behind your deep learning model. With all these 3 inputs, there will be some mathematical process inside your deep learning model based on the model parameter values are available. I said that these are the model parameters, right? So like a model parameter value W1, model parameter value W2, W3, W4, W5, W6, W7. So multiple model parameters are there. That going to update. We are going to update those model parameters. Okay, that we will discuss in later. So based on these model parameter values, based on the coming inputs, your deep learning model gives some prediction. This is called as your predicted output. This is called as your predicted output. So TDYP, it is called as the predicted output. Simply, I will call it as a YP. That means predicted output. And this predicted output depending upon what? This is depending upon these model parameters and also these inputs. Because these model parameters and these inputs have processed and it will give the output. Right? So the predicted output will be depending upon your inputs and also your model parameters. Then inputs you can't change because this is coming from the data. So your finally what things in your control, that is called as the model parameter. So ultimately I can say that my predicted output will be mainly depending upon the model parameter that I have. If I change these model parameter values, these values will be changes. The prediction will be changed. Fine. Okay, for these three inputs based on the available model parameter values, I am getting the predicted output. Now my predicted output is compared with my actual output. This is my actual output. So this actual output is compared. My predicted output is compared with my actual output. So I will call it as my actual output equal to Y. My actual output equal to Y. Right? Now you can see what the error? Error equal to Y minus YP. So this is my error. Actual output Y minus predicted output YP. The difference is called as the error. If I want to calculate the square error. If I want to calculate the mean square error, let us assume I'm passing the one sample at a time. Then the mean square error equal to 1 by 1 only. Half mean square error means half. This is called as the half mean square error. Okay. Now, training of any machine learning model or deep learning model is nothing but minimization of this half mean square error. So what it will happen? What is the goal of any training process of the machine learning model or deep learning model? What is the final goal or what is the motto of any training, either for the machine learning model or deep learning model? What is the motto? What is the goal? It's trying to train the machine learning model or deep learning model such that the model is going to predict the output YP, which is close to your actual output Y. That means the error should be minimum. The main goal of the training process for any machine learning model or deep learning model is to machine learning model or deep learning model should predict there is a YP which should be close to your actual output Y. So if YP is close to Y, if the YP value is close to Y, then what is the error? It will be minimum. So that's what minimize half mean square error. So the main goal of any training process for any machine learning model or deep learning model is to minimize the error or to minimize the difference between the actual output and predicted output, or to get the predicted output more close to your actual output. That's what, right? If you are building one application to predict the temperature, we are expecting the predicted temperature will be more close to your actual temperature. Otherwise, it's no use. If you're developing some deep learning model for a disease diagnosis, you have to predict if the person don't have a disease, you have to tell no disease. Your model should tell no disease. If the person has a disease, your model should tell it is a disease. If you don't have a disease, but your model is saying that disease is there, then it's not good. So whatever the predicting, that will be close to your actual values. If the predicted value actual values are more close to each other, then the error will be less, minimum. That is the ultimate goal of any training process. So minimization of the half mean square error is the ultimate goal for any training process. Okay, hope you understand, right? Then, so minimize. So error equal to 1 by 2 actual value minus your predicted value is depending upon your model parameters like W1, W2, W3, W4, W5 whole square. Right? So you can see now I'm saying that it is a training of a deep learning model. But I am seeing this one as a optimization problem because minimizing an error, minimization of particular objective function is optimization problem. Now my training goal is I'm trying to train my machine learning model with a goal of minimize the error. So when the error will be minimized, your y is the actual value, it will not change. It is from the data set. Only you have to update your model parameters W1, W2, W3, W4, W5 such a way that your predicted output, this is called as YP, is close to your actual output. So what these W1, W2, W3, W4, W5, as a machine learning engineer, I am calling this one as a model parameters. But if I may the optimization technique apply, I can call it as the decision variables, because these are the variables which will decide your YP value, which will decide your error value. Hope you understand, right? Okay, so this is how your deep learning models will be trained. So I'm trying to write further. So this is my deep learning model with some model parameters. I will give some inputs. Based on the model parameter, it will give the output. That means predicted output, YP. And this predicted output is compared, this predicted output so this predicted output is compared with the actual output. This is the predicted output, this is the actual output. And whatever the error is there, that error, that's nothing but the 1/2 into y minus yp whole square. This error will help to update the model parameters. When the model parameter updated, then yp value changes. Okay, hope you understand. In case of the deep learning model, your optimization technique will help the deep learning model to update the model parameters such a way that your predicted output is more close to your actual output. Such a way that your predicted output more close to the actual output means your error will be minimum. Right? So that is the ultimate goal of your training process. The ultimate goal of your training process of any deep learning model is to update the model parameters in such a way that the predicted output value more close to the actual value, so that error will be minimum. So error will be minimum. So that's called as your optimization problem. Now you can use the gradient descent algorithm to update your model parameters so that your error will be minimum, so that your predicted output value will be more close to your actual output value. So this is how your optimization will be very, very useful in case of the training process of your either machine learning model or deep learning model, parametric based models. I think it's clear. What I'm saying. I think you are trying to understand the need of optimization in case of the deep learning model training or the machine learning model training. So whether it is a deep learning model or machine learning model, inside the deep learning model or machine learning model, you have some model parameters. Okay. And what are the inputs you are given? We are performing some mathematical operation inside the deep learning model using the inputs and also using the model parameter, and it will give the predicted output. And the predicted output is compared with the actual output, and whatever the difference, that will be the error. That error will be given back as a feedback, and based on this error, this model parameters will be updated in such a way that the predicted OEP value more close to the Y value, predicted OEP value more close to the Y value, so that error will be minimum. So that means minimize 1/2 y minus yp whole square. It's like a non-linear optimization problem. So deep learning training can be called as non-linear, unconstrained, because there is no constraints, unconstrained, and multivariable. You have the multivariable. Why sir it is the multivariable? Because your yp is depending upon the multiple model parameters. Not a single model parameter. You have the multiple model parameters that depending upon the multivariables, multiple model parameters. That's why it's called as a multivariable. Okay. So I hope you understand. So now to solve this problem, we all know how we solve non-linear, multivariable, unconstrained optimization problem using the gradient descent algorithm. Now that gradient descent algorithm I will apply to train my deep learning model. Hope you understand, right? So this is the complete need of optimization, gradient descent optimization for the deep learning models. Okay. So this is the session for today. So this is the complete session.